The first formula for differentiation is differentiation of constant with respect to x is always 0. So how you can remember it? Actually, even if you change the values of x, constant value will not change. So change in constant is 0, that's why this ratio is 0. So for dc by dx is equal to 0, where c is the constant. So remember it. The second formula is d by dx of c dot fx is equal to c dot d by dx of fx. What is the meaning of this? If you want to differentiate the multiplication of constant with fx, this is equivalent to multiplication of constant with differentiation of fx. So in this formula you can easily take out the c from outside and you differentiate the function fx. So example of this formula is, suppose you want to differentiate c, take any constant, that is 3, and fx, take any function of x, suppose 4x plus 1. So this is equal to, you can take out the 3 multiplied by differentiation of f of x, means 4x plus 1. So differentiation of 4x plus 1 is 4 into 3 is equal to 12. Third formula is differentiation of sum of the two functions. Suppose there are two functions, one is fx and another is gx, and if you want to differentiate the sum of the function, this is very simple. You just differentiate individually and add it. So it is equal to differentiation of fx, that is f prime x, plus differentiation of gx with respect to x, that is g prime x. Similarly, differentiation of fx minus gx is equal to f prime x minus g prime x. The fourth formula is, if you want to differentiate the multiplication of the two functions, suppose first function is fx and the second function is gx, and this whole is the multiplication of fx and gx, it is equal to fx dot g prime x plus gx dot f prime x. What is the meaning of it? Actually, how you can remember it? First portion is came out by assuming that fx is constant. So if you treat fx as constant, take it as it is, that is fx, and differentiate gx, that is g prime x, and in the another part treat gx as constant. So take out the gx and differentiate f, function of x, with respect to x. So there are two parts. You have to differentiate both g prime x and f prime x, and you have to multiply other part also. Suppose you require to differentiate the multiplication of two functions, assuming that the first function is 3x plus 4 and the second function is 6x square plus 4. So according to the above formula, what you need to do is first differentiate this second function and treat first function as constant. So 3x plus 4, if you treat this function as constant, multiplied by differentiation of this function with respect to x, that is 12x plus. Now treat this function as constant and differentiate 3x plus 4 with respect to x. Differentiation of 3x plus 4 with respect to x is 3. So treating this as constant, 6x square plus 4 multiplied by 3. So it is equal to 36 x square plus 48 x plus 18 x square plus 12. 36 plus 18 is 54x square plus 48x plus 12. So this is the answer. Here in this formula you are required to find out the differentiation of function of x. This is a very tricky type of differentiation. What you need to do is that treat gx as another variable. Suppose u is equal to gx. So remember, if you put u in place of gx, it becomes like this: dy dx of f of u. If you expand this according to the formula, this is equal to df by du into du by dx. So du by dx is nothing but g prime x, means differentiation of gx with respect to x, that is g prime x, and df by du is nothing but f prime of gx, means you have to differentiate the function with respect to u. I will explain it by example here. Suppose you are required to find out the differentiation of this type of function: 3 multiplied by x square plus 1 whole cube minus x square plus 1 to the power square plus 2. So here you are seeing two functions. The first function is fx is, if you treat this as u, so u becomes 3u cube minus u square plus 2, and u is x square plus 1. So the differentiation of it will be df by du multiplied by du by dx. So the first function is f prime of gx, and the second is g prime x, that is equal to, because fu is 3u cube minus u square plus 2, so the differentiation of f with respect to u is 3 into 3, that is 9u square minus 2u, and differentiation of u with respect to x is 2x. So if you take this u out, u multiplied by 9u minus 2 multiplied by 2x, and you if put the values of u is x square plus 1. So if you put x square plus 1 at the place of u, you will find that is equal to twice x into x square plus 1 multiplied by 9 into x square plus 1 minus 2. So the final result is twice x multiplied by x square plus 1 multiplied by 9x square plus 7. This is the final answer. The seventh formula is differentiation of x to the power n with respect to x is equal to n into x to the power n minus 1. So what you need to do in this formula is take this n and multiply it with x to the power n minus 1, reduce the power with 1. This is the formula. Suppose d by dx of x to the power 5 is equal to, take this 5 out here, 5 into x to the power n minus 1, that is 5 minus 1, it equals to 4. This is a very easy formula, you can remember it very well. For differentiation of a trigonometric function, if you remember some certain rule, then it will be very easy for you to remember the formulas. So here the main formula that you require to remember is differentiation of sin x, cos x, tan x, cot x, sec x and cosec x. What you need to do is divide the sin x and cos x in one group, tan x and cot x in another group, and sec x and cosec x in another group. And the rule will be similar. For sin x, differentiation is cos x, and for cos x the differentiation of it is minus sin x. What is common in all the three group is that for every second one the differentiation have minus sign. Here in cos x also minus sign, cot x also minus cosec square x, and cosec x, differentiation of cosec x is having minus sign. In the first item there is no minus sign. What you need to do in first group, just change sin to cos and cos to sin, and sin you remember. The second one is having minus sign. Okay, so minus, minus and minus. So in the second group the rule is that differentiation of tan x is equal to sec square x. How will you remember this sec square x? You remember this cos x. What you need to do is reciprocal if cos x is sec x. You require two extra work. First is to find out the reciprocal and then square it, that is sec square x. Similarly here also, reciprocal of sin x is cosec x and then square it, so minus cosec square x for cot x. And for sec x and cosec x, you are required to remember that the item will remain same here for first, and multiply it with, for sec x multiply tan x, and for cosec x multiply it with cot x. How will you remember tan x? Here from this formula you can remember tan x is related with sec square x. That's why sec x, from if this is sec x, you take tan x, and if cosec x is here, you put cot x. For logarithmic related to differentiation, there are three formula that you require to remember. First is Euler's number to the power x, e to the power x. This is very easy. This is one of the most easiest formula of differentiation. The differentiation is same as e to the power x, so there is no change in any value. D to the power dx to the power to a to the power x is equal to a to the power x into ln of a, log natural into a. So a to the power x is similar to e to the power x, but it is not same, so there must be something will come here. So output is same a to the power x, but one multiplication came here, that is a. Take this a at ln a. So this is the second formula, and d by dx of ln of mod x, because you cannot find out the logarithmic value of negative value, so there always be a mod value of x, and this is equal to 1 by x. This is easy to remember, just 1 by x, you just remember log of x. Okay, now I will explain last 6 formula of differentiation. This is sine inverse x. If you want to differentiate sine inverse x with respect to x, you just equals to, you just put 1 by under root 1 minus x square. So the main problem is how to remember this. So you know that any sine of any value is always less than 1. So here 1 minus x square, you can take the root only for the positive, so x will always be less than 1 or equals to 1. So 1 minus x square, that it will make it positive. As you remember from earlier, alternate is negative, means differentiation of cos x is negative. So put the minus sign here, and the value is exactly same, but only sign is different here for cos inverse x. So differentiation of cos inverse x is minus 1 divided by root of 1 minus x square. Only minus came here. This is first type of differentiation, sine inverse x and cos inverse x. This is in one group, first group. In the second group, there is 2 type of differentiation, tan inverse x and cot inverse x. Also the result is having only minus is having in cot inverse x, differentiation of cot inverse x. So how you can remember this? Everything is positive in this tan inverse x. 1 plus x square is also positive, 1 is also positive, and plus sign is positive. So 1 by 1 plus x square, there is no root, you just remember in this way. And for cot inverse, just put minus sign on above. And last 2 is sec inverse x and cosec inverse x. So basically it is similar to above one, but having 2 changes. The first is x square minus 1, x is always greater than 1 for any value. Cosec x means sec x and cosec x value is always greater than 1 or equal to 1. So to make a root positive, x square minus 1, you require to put first x first. So x square minus 1 is positive, and here also you make positive by mod x. So 2 changes done. The one is change the location of x square, and another is put mod of x from cos inverse x and sin inverse x differentiation, and minus sign is as it is. For cosec inverse x, put minus. That's it. So in this way you are required to remember all the formula of differentiation.